Just starting the recording. Just a minute. Yeah. Yes, we are
Oh,
recording now.
all right. Good evening, everyone. Good evening to R for Beginners, an online short-term training program that is being conducted by the Department of Travel and Tourism, Vishwakarma University, Pune. I am Remy Thomas. I am one of the faculties of the department, and I welcome you all, the participants. Today is the fourth day, and of and tomorrow that will be the last day of this short-term training program.
Okay. I can't hear you, Professor Remy. Okay. Others can hear me.
Yes, sir. We can hear you.
Okay. I think there is some end problem from the Professor Remy's side. So it's okay. I guess we can start the session. Okay. Okay. So like the last time, before we go for today's session, which is about the data wrangling, do we have some queries or questions if you have practiced in case? Okay. If not, and how many we are? 10 now. So should we wait just a couple of minutes and we can discuss few questions? Some more people will join being time. Do you have some queries from earlier sessions?
So just a little query, sir.
Yeah.
So in the packages, there are some ticked packages and there are some unticked packages. So what do they signify, sir?
The ticked packages, like let's see live example. Okay, if the package is ticked, it means in this present R session, R project session, you are using this package.
Okay, sir.
Yes, and this is also one way if you want to manually call some package to be active in your R studio. So you can tick directly from here, but still it will be part of your R console, but it will not work in your script. So the best part is, or the best way is to write the library and the name of the package so that it will work in your script.
Okay, sir.
But if
Yes,
you
sir.
just want to work in the console, like which is here, if you just want to work in the console here, then you can tick here and then it will automatically work in your console. And if you untick, then it will not work. Yes.
Okay.
Few packages, even if you do not tick them, they are automatically ticked because or take the help of some basic packages which will help you, to run the things. So it will automatically, like base package, it is already ticked automatically, right? So that is how it goes.
Thank you, sir.
Welcome. Okay, so we are 13 now. So I guess, okay, yeah, you can check like people whom with you attend every day or all are here. Those who are regular, at least, all are there. So, or you are thinking that one person is regular, but if you wait a minute, they will join. Mhm. Being time, I can make this correction because in my title still I have written visualization, but it is Wrangling, Wrangling. Yes, it is wrangling now. Okay, I guess we are 13 now and we will start the session. Okay. So very good afternoon to all of you. And this is the fourth session or the second last session of this training R for beginners. And today we are going to talk about the data wrangling, which is the module number 4. And then tomorrow we will having the last session of this training, HTML slides, or you can also say the slides using the Sheringan R package and how to make HTML slides. So we'll use that slides like this, which I'm using right now. And I am your instructor trainer for this course as well as this session. My name is Ajay, and our journey of this training course, we covered the module number 1, where we covered the basics of R. Then we covered the module number 2, where we discussed R Markdown and how to create dynamic documents. Then in the third module, we discussed package ggplot2 and how to use ggplot2 to make the visualizations. And about the visualizations, we just cover very basic, actually, just the foundation, just to give a very, as the title says, it is a training for the basics. So uh, it just give you how to arrange the bricks. We did not form anything much there. So it is just like understanding, okay, what are the basic structure. So, but there is a huge, so many things to learn and huge opportunity. Even if you just specialize yourself in data visualization, uh, definitely you can get a good job and a good opportunities, and you can improve your research outputs, right? So today we are going to talk about the module data wrangling using dplyr. Now, yes, data wrangling using package dplyr. So like this picture I kept here. So so how to reshape your present data. Like you can minus something from your present data and keep it separately, add something, increase the size of it, and adding more variables, more data, how to do that. Minus something, so make it more small, so like transforming your data completely. So how to do that? And in data science language, it is called as wrangling, data wrangling. Okay. So, and if we go with our course progress, so we learn the visualization, we learn the communication part, and now we are learning today the wrangling part, like how to import the data, how to tidy the data, and how to transform the data. So we will be covering mainly the transformation part and not much on the tidy and import. Import we already covered in the last session, how to import the data from CSV or the Excel file. Still, if any of you feel that we are facing problems, so we can repeat it again. So mainly we will focus upon tidying and transforming the data. Now, as per the academic books, how they define data wrangling. So if by the book by Jessie, she says data wrangling is about data exploration and data manipulation. And I don't know, somehow when we listen the word manipulation, it sounds to us like, we are going to make some changes in the data which are not ethical, or we like changing the data. No. Manipulation is a word which comes from the craft, and manipulation means how do you change it by using the technique. And that doesn't mean you cheat the data or you make some changes which are unethical. No, that is not what the meaning is here, right? So data exploration, you go through the complete data, find out the pattern, and find out what are the different variables are there, what are their different types, and then you manipulate them, like calculating new variables based upon the existing variables, or completely changing how the data is arranged. Okay, like and then one more definition is from Hadley. He says that data wrangling combines two important tasks: tidying the data and transforming the data. And what do you mean by tidying? In R and in most of the research what I have seen, we always expect our data should be in this format, which is called as tidy format. And tidy format means each column represents one variable. Like this is variable country, this is variable year, this is variable cases, this is variable population, right? So each column one variable, and each row represents each observation. Like this is observation 1 and then data, observation 2 then data, observation number 3 and then data. And then each of that junction, like cross section of column and row, represents a unique value. Like these are all are the, I should not say unique, but these are the values. Okay, so they represent the values. So this is called as tidy data. And you will listen this word tidy a lot in the learning sessions of our data science. Tidy words, tidy data, tidy plots. So yeah, so just get used to it. Okay, then okay, till here is fine, I guess. So now let's go one more layer inside. Now, what is the meaning of transforming? So when we say data wrangling means transforming the data, so what actually we mean by it? Okay, so transforming means narrowing in on observations of interest. So we continue in this session as well with the data penguins, which we started in the last class. And so if you remember a little bit from that data, and if not, you can take the help of the help function and you can again find the information about the penguins data. That we have the data about the species, about the islands, about their bill, about their weight, about their sex, about their year, right? So, uh, right. So I guess someone has to mute. I'm just getting keyboard's noise. Okay, right. Remy sir, can you please check and mute? Yeah.
So it was me actually. I have just joined. I was in
Done,
the
done.
lecture. Just the lecture got over, and I joined, and the mic was by default unmuted.
Okay, no issues, no issues,
Sorry.
no issues. Yeah. So by transforming means we want to narrow down to the observations of interest. So let's say in this data of the penguins, we have all different variables, but we want to focus upon one particular species. So how to transform our data to change that data in such a way so we focus only one particular species. So and in Excel, how do we do? Either we delete the variables or we make a new data and then, or we hide the columns, right? That's what we do, or we freeze them. So make the all the possible things so that we can remove some variables from our analysis. So I won't be able to say much about Excel because thankfully I stopped using it very long time. So it is only a tool for me to save the data. Okay, that is the best thing it can do, save the data, right? So yeah, so that is one purpose of transforming, narrowing to the observations. Because let's say at the stage of data collection, you collected 50 variables, but in this particular research work, you want to focus upon only the 20 variables. So what will you do? Most probably you create a new data set and then you say, okay, I will delete the 50 and keep the 20, right? But while doing the analysis, you thought, okay, I should bring one 21st variable also. So then again, you have to copy from the main raw data, one more column into the Excel sheet. So all this cut, copy, pasting can create a lot of what do you say distraction, because already we require a lot of focused attention to do our research work. And when we do all this cut, copy, pasting, it makes our work more tedious, very difficult and boring, of course. So why not take an approach where your main Excel or your main data is intact, and using or taking the help of the codes, you are doing all the changes with the file without even touching the file. Okay, so that is how transforming of the data will help us. Now another one meaning of or one more meaning of transforming the data is you want to calculate, we want to calculate new variables based upon the existing variables, right? Because sometimes it makes sense. Let's say you want let's what we do in the research when we are having Likert scale. So each statement of the Likert scale represents one column, and then we need to combine all those to finally calculate the scale, right? uh, so uh, so it means if there are 5 statements and you have to take the score of all the 5 statements, and then you have to calculate finally the value of the score of that scale. So new variables, creating or measuring new variables based upon the existing variables, that is again one more task. Or let's say you recorded the data or you collected the data in one measurement units, let's say in centimeter, but then you want to convert it into millimeters. You collected it in the years, but now you want to convert it into months. Okay, so it depends what requirement we have, but in general, I know we have to calculate sometimes new variables based upon the existing variables. So there also dplyr or the transforming or the data wrangling helps us. And then calculating is summary statistics, like how to calculate the what do you say, cross tabulations. I can say cross tabulations, like if we have categorical variables and then we want to know how many respondents in that particular category, and based upon that, if you want to do some calculations, then again you need transforming the data. Okay, so and there are many more things which you can do with it, but we will focus on these three aspects. Do we have more? No, I guess yes. So narrowing down on the observations on which we are working further, creating new variables, and uh, creating summary of the statistics of the data, and then using them for making tables, plots, and other things, right? Okay. So before I start about the R package dplyr, and as you know, you see this logo, which is having a plier. And if we all know in plier how we use in the home to twist the things, change the shapes of the wires, cutting the wires, making them short, or all those things. So same work it does here. It make changes in our data according to our requirement. Okay, before I go further, I would like to ask, like, if anyone, if you have any question, or like still it's not making sense what I'm trying to say or what we are going to do, so you are welcome to ask a question, or you can just say quickly no, 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 so I understand that we are following.
No, sir.
No, sir.
Okay, thank you. Okay. So dplyr package, it is a grammar of data manipulation. So dplyr is a grammar of manipulation. So again, we have the systematic rules. Everything has a logic why that particular function is set. So it's a grammar of data manipulation. Like in the ggplot, we have grammar of graphics. Gg means grammar of graphics. So it is a grammar of data manipulation. And now dplyr package provides you consistent set of verbs. Verbs means we all know verbs. Okay, so it provides you some verb based actions which helps you to do the manipulation in your data. So, and these verbs are like filter, select, mutate, arrange, and summarize. And as we go with the name, filter means this function will help us to filter our data based upon the observation, right? Which observation you want, which observations you do not want. So if you have this kind of question in front of you, we can use the function filter. Then we have the function select, which variables you want to keep, which variables you do not want to keep in your data. You can use the select. Mutate, if you know a little bit about the biology, so there is one word called as mutate, like X mutates and become XY or X plus 1, something like that. So it is no more what it was earlier, but to become something, it needs the X, right? So mutate means creating or measuring a new variable based upon the earlier variables. So the function is mutate. And when we want to arrange our data based upon the value of one particular variable, so we can use the arrange. And then to measure and to calculate the summary statistics, we can use the function summarize. Okay, so and one more function we're going to use, that is group by. That is also very important function, group by. So like grouping all the data values based upon one particular variable, right? So these are the important, there are several functions in the dplyr, but these are the some of the most important and the basic functions which we can use, and we can really make our data to get ready for the analysis, right? And I'm sure most of you have some sort of research experience like data analysis or data cleaning or collecting the data, you know that it takes a lot of time to bring data into a shape and so that we can start the analysis. It never happened you will get a very fantastic data and then you just start the analysis. No, we have to make uh, several changes after bringing the data, collecting the data, and then going for the analysis of it. Okay, and one more thing I would like to add here is that um, let me give you one very simple example. uh, let's take the example of social media usage, and let's in the future some of you have joined a media company, social media company, as a data analyst. So you see, on any social media platform, so let's say I'm active on Twitter, so I will take the example of Twitter. You have the likes, we have the retweets, we have the comments, right? And then we have our own tweets. So all these options are getting saved as data. Okay, and how they are getting saved, that is the work of a data engineering. That is not the work of data scientists, that is the work of data engineering. And they will make the programming in such a way so that all those data got saved, right? But that is the work of data engineering. But after that, once that data is downloaded from the servers, now it's the work of data scientists to do the analysis of it, right? Now do you think that all those likes, all those retweets, all those number of tweets will be nicely stored in a very nice format so that you just take the data and start the analysis? No, they are not. So as a data scientist, you have to bring that data into the format where you can start analysis on it. Okay, and it is quite a tedious and quite a time-taking activity, right? And initially, until unless you reach to a senior position of a data scientist, your 70% time will be going into that. Until unless you have juniors to do that work, okay? So most of the time will be going into the data cleaning, data tidying, and transforming the data. And then your seniors will say, okay, data is ready, now give it to me, I will do the analysis. Okay, so that is the benefit of being a senior. Yeah, but all these actions are important. So like I'm also trying to aware whatever I know a little bit how actual data science works. It is not like the way it has been shown in the media, or some of our friends says ki, yeah, it's so fascinating, or we imagine about them ki they must be like we saw in the movie, handling the computer so fast, and just modeling and all. Modeling is part of that, and that take very less time actually, but maximum time is taking to bring the data into the format so that it is ready for the analysis, right? Because if that is not correct, your whole analysis will be wrong. Okay, no, if your data is not in the format so that your tool can understand it, so how any proper analysis is possible? So it is a very important skill, is a very important task ki we collect and save data in such a format so that we have to do minimum effort of cleaning it and taking care of missing values, and then getting ready for it for the analysis. So just yeah. Now let's start the first function, and that is filter function. And I hope all of you are working in your RStudio project, and in your progress document, you can create a main heading, and then you can say key data transformation, and below that you can do today's work so that you have a track key what did we learn. Okay, so as this picture shows, filter function picks cases. Okay, sample has different name. It has observation, sample, cases. All are the different synonyms for the observation. So like 1, 2, 3, 4, 5. So these are called as cases. Okay, so pick the cases based on their value. So when you told I want this value, so filter function will take only this value. It will forget all the values, but it will just take only this value. So this is how filter function works. And now let's take an example. Okay, so now the problem is, if you remember about our penguin data, and again let me show you how to get the help here. So you can write help, And yes, we already have the penguin data here. So we had the different variables here, species, island, and everything. So my question here is how to have a data of only Ginto penguins. So we know uh, there are three types of penguins: Adelaide, Chinstrap, and Ginto. But I do not want Chinstrap and Adelaide. In my data, I want only Ginto. So I am filtering the data based upon a observation value. And what is the observation value? Observation value is Ginto. I want only Ginto, right? So the command which I'm going to use here is I'm going to say penguins, and I'm just writing penguins because already I activated the library Palmer penguins. Then only I'm able to access the penguins data. And then I'm using this thing. It is called as pipe, and I will be explaining it. What is this and how it works? It is percentage greater than and percentage. And shortcut to bring pipe inside is it is Control Shift M. Control Shift M, or yeah, try Control Shift M or Alt Shift M. Can anyone confirm which one is working? Control Shift M?
Yes, sir. Control Shift M.
Yes. So just keep a separate note somewhere so you remember that to introduce this pipe automatically, we can press Control Shift M together. Okay. So, and I will explain what it is. Okay. So this is just data, then put this, and it's called as pipe. And then we use the function filter, and then we say species because we want to filter based upon the variable species. And exactly we want a value equal to Ginto. And I mentioned earlier as well, equal to in data science is in R represented by double equal to, not a single equal to. So double equal to means exactly equal to. So and you know, in the variable species we have three factors: Adelaide, Chinstrap, and Ginto. So what I'm saying here, filter the whole data based upon the variable species, and in species also the value is should be exactly equal to Ginto. Okay, is it making sense till here? I can hear some yes or no.
Yes, sir.
Okay. Okay, so now
Yes,
let's
sir.
see the okay, now let's see the output. Now if you see the output, you have now 124 penguins data only on the 8 different variables. So earlier, what was the sample size? Anyone remember what was the sample size? What is the total number of penguins? 300 plus, if I'm not wrong. It was somewhere around 300. So now we filtered it only with the value Ginto. So now our data has only 124 penguins, and all these are Ginto. If you see here a glimpse, if you see, all are Ginto. Okay, right? We all are Ginto. Of course, we have a small screen, so we are not able to have all the values, all 124 values, and it doesn't make sense also why to repeat, but we are getting an example how we are having. Okay. Okay, till here everything is okay. Like, are we able to follow what is happening?
Yes, sir.
And I guess that yes is coming only from Siddhant, I guess, if I'm correct. No?
Yeah.
Okay. What about others? What about others?
It's okay, sir.
Yes, sir.
Okay, we are going okay, right? So
Yeah.
okay, thank you. So let's now, okay. Then there is one more function. Why it came? 1 second. Okay. Now, what I also wanted to show you here, you need not to see the default output of R just like this. You can also represent the output in the form of a nice table. And this thing, which is called as pipe, it can help you to combine several functions one after another. Okay, so let's say what I said here, penguins means access the data penguins, pipe, then filter the data based upon Ginto, then pipe, and then summary. Give me the summary. We learned this function in the last class, summary function. It will give you the summary of all the variables. And then we also learned the last class a function to make a table, right? So we are using the package here, cable extra, and convert into a nice table. So like, and now if you see the output, your output will look like this, a much better presentation of your data in a somewhat good table. So you can see the species Adley 0, Chinstrap 0, Ginto 124. Okay, can anyone tell me why we have Adley 0 and why Chinstrap is 0?
So because we put it as species, like the filter was at Gento, like, and not for the other two. So that is why we'll get both of them as 0 and Gento.
Exactly, yes. Because we especially asked, we want data only for the Ginto species. We do not want Adley, we do not want Chinstrap. Right? And then we got the summary for all the data, but only for the penguins which are Ginto. Right? So now let's see how to export this changed file to your computer. Yes, please.
What was the cable extra doing over there? Like what was
Cable extra is a package to convert your output into a table. Like you see the difference in the output. There is a gray, nice code, everything, gray and white table. Are you able to see?
Yes, sir. Yes, sir.
So these changes are done by the cable.
So essentially, to summarize it in a table, we use the package cable extra to get this in it.
Cable extra is a package to make nice and beautiful tables in the R. Yes.
Okay.
Like if you are having HTML output, so like I did not give any default, so it is making a default HTML. And so this is the HTML output where you have one line gray, one line white, so that you can easily read and make a difference. This is a table. Yes. Earlier, you remember earlier when we were writing summary, how the results were coming, right? So these results are much better than just writing this summary.
Also, the values that we have for the rest of them, let's say, even if we don't have Adele or Chinstrap and everything, but we do have the minimum, and the first quartile and everything. Are they reliable, or are they just like something that's been given just for the?
No, they're 100% reliable.
They're reliable, but
yes,
yeah, okay.
Yes. These are the exact values R is measuring based upon the summary function, and complete calculation has been run. So when you talk about the body mass, so this is the mean body mass for all the Ginto penguins. It is correct.
Okay.
5076 gram. It is a calculated value.
Okay.
Yes.
Sorry,
Yes.
Thank you.
Yes. And the maximum weight in the Ginto penguin is 6,300 grams. Okay. And the median value is this, mean value is this, and minimum value is this. Okay. Yes. So these are ready to use tables. Yes. Yeah. Then okay, now how to export this new data file into your computer. So in case you have made changes, but you want to change, you want to save this new data file in your computer. So the function we are going to use is write_csv. And yeah, first we have the data, then filter it the way you want to filter it, and then use the function write_csv. Like yesterday we use read_csv to import the file. To export the file, we say write_csv. So write this file as a CSV in your computer, right? And in this function, we have to give where you want to save. I want to save it into the folder data. And what is this? The file name? File name is ginto-penguins.csv. And if you run this in this particular folder, and that folder, I think you should have already created that folder, and then you should run this data folder. Or I'm not sure if you just do without creating and run it. Let's see whether R will create the data folder, or it will ask you there is no folder with the name data. Most probably it will give you an error if there is no folder with the name.
There is an error,
yeah, it will give an error. So first is you have to create one folder inside that and write data. Then it will save this file inside your this data folder. Now let's go and check this new file. Where is the data folder? This is data folder, and I created this new file. So let's see this new file. I'm sorry, this computer is a little slow, so I'm just managing. Yeah. So now if I increase the size, and if you see, all data here is Ginto. All data is here is Ginto. Okay. All data here is Ginto. Right. Right. Okay. Now let me show you one more beautiful thing why we should use data science for analysis. Right. Where is our? Yes. Just now we calculated this. So Siddhant, as you are following, so I just ask you. So you just note down what is the mean value now for the body mass. Please note down 5076. Right. Okay. Are we there?
Yes,
Hello?
sir. Yes, sir. Mean is 5076. Yeah.
Yeah, please note down this because we're going to do something. That's why I'm asking you. Just note down the mean value is 5076.
Yes, sir.
Now, let's say you came to know that some of the values in your data are wrong. Okay. And you came to know that you have to change them. So let's say some of the data values are, these are the new data values. So in this case, now your data values are changed. So what we will do, we will do the analysis again. Then the new tables will come. Then again, we'll copy those tables and replace the old tables, right? But that is the one best thing here, which I like it. You change the values in your data, save the file, okay? And if you run your codes again, let me just save it again. And now let's see, our values should be changed here. I hope. No. Did it change? It did not.
Sir, no, it's the same.
But let me close the file. Let me just try. Because it's supposed to change, because why it is not changing? Let me guess why it's not changing. It is not changing because we are making this table from this particular data, not from the data what we have already, right? So if we want to change it, so let me bring this data here, then change it. So let's get it done. Okay, so first we need to import that data. So what was the name of that? 1 second. So we want to import, let's say name is p raw, and we want to read underscore csv and from data, and the second name of the data is into penguins.csv, and now we should be able to access this data, right? I hope if everything is correct, we should be able to see some changes now. Okay. Still no changes, right?
Yes, sir. No changes yet.
Still no changes. 5076. But why? It should change because we changed the data. We changed the data, so it should change. 1 second. Let me try to make more changes. So maybe it is taking a.
So maybe the changes are very minuscule, like from their values, and maybe it's taking an.
Oh, but it did not see our changes are not saved. See.
Oh.
Body. Okay, you know what is happening when we are saving this? It is that it is creating a new file actually. Okay, wait, I got it. What is happening? Yes. Let's make a copy of this. Because same time that earlier code is also running, right? So it is updating it to the latest one. Yeah, I got it. What is happening? 1 second. let's make it 1 now. And now let's make changes in this file. Now even, yeah, it should reflect, yes, because we changed these many values. That is a big change. So now it should change. Okay. Yes, what is the mean now?
4985. It was previously 5076.
Exactly. So see, that is the best benefit which I found of the data science, that you need not to cut copy paste anything. If you change any values in your data, your results will be automatically updated. Okay, I just ask you to remember only one, but if you see, all the values are updated based upon the new data or the new data changes. Isn't it fantastic?
Sir, but in the end, we also had to create another one because we were using the previous one, right? Like we had to make a different copy of the file, and then we
No,
had to make changes.
why in this case I need to make a different copy? Because when I'm saving this file, same time I'm running this file also, no? So it is
Oh, acha. So
updating to the latest one.
there is a conflict. Okay.
Yes, yes. That is why I was shocking ki how I changed it, how it became updated. Because when I was running earlier command, this command is also running, right?
Also running the same thing. So obviously, any
Yes.
changes we
So
make will not be reflected in it.
yes, it was not reflected.
But ideally, if we go ahead and we do it, all of that will be reflected back in our original source code.
Original source itself.
Okay.
Yes, yes.
Okay.
You need not to create another copy. Yes, yes. So this is fantastic, and I really appreciate. That is the one big reason that I stick to it, because I need not to worry about the changing the values in my output, so that my plots, my tables, and all the outputs will be automatically updated. No more I have to worry whether I change the values, whether my new plot is there or not there. So all those worries, you can keep it aside, and I think it is a fantastic way to not to worry about the copy pasting thing. Okay, we are more focusing on the work and then just on the copy pasting thing. Okay. So this is done. So we learn how to write the file. We also learn that if you change, if you make changes, in the file, and then you can update your results automatically. That is nice. Okay. Now next thing. Now I'm going to explain what is this. Okay. So this is called as pipe, and the way to introduce it in the R slides is the Control Shift M, and the why it is called a pipe, because it's a powerful tool to connect the multiple operations together. If you remember in the ggplot, we were writing plus, okay, and everywhere else, if you want to use pipe, you can use if you want to connect the multiple functions together, we should use the pipe. Okay. Now, why not in the ggplot? Because when ggplot was formed, the pipe was not developed, and it was not now in the position to change plus sign and replace with the pipe in ggplot 2, because ggplot is a very mature package, and it is very difficult, or maybe impossible not to change it now. But in the new functions, every time we are using the pipe. Now, how to understand the pipe? You read pipe like then, word then, like call data, then I want to filter this data based upon the variable species, based upon the value ginto. Then I want to write a summary of this. Then I want to make a table of it. So it is like a poem, one after another, or in logical steps, one after another. First you have the whole data. Then from that data, I want to filter it based upon the ginto. Then whatever I have filtered, now make a summary of this. Okay. And now just do not show me the summary. Convert that summary into a nice table also using the function cable. So we are connecting first operation, second operation, third operation, fourth operation with each other through the pipe. Okay. How many are happy with it, or how many are thinking, oh my God, one more thing to remember? Or is it making little sense or not? Like, but this is the way to do it. So I don't know if it's good or bad, but that is how it goes. And it is very powerful, because you can connect more than one functions together, right? So, and this is the way actually to make one of some of the best data visualizations, because you connect multiple operate functions with each other. Okay, I can take a seconds of pause if you want to digest it and have some questions about it.
Sir?
Yes.
So I'm getting the output, but not the table, sir.
Okay. Did you write library cable extra in your document?
Yes, sir.
Yeah, because you need library cable extra to make the table.
So I wrote it, sir.
You wrote it? Okay, so let's try. If you want to check me, if you want me to check, let's copy all this and open our progress document. Where is our progress document? This is our progress document, and let me add where I should add. Okay, let me add here. Okay. Say session 4. So everything related to that work here. So let's have a chunk and have the codes. Now let's save them and see the output. Session number 4. Okay, yeah, okay. Is your table coming like this?
Yes, sir, sort of.
Yes. Why? Because we need to add one more function here, which is called as, and I forgot to comment, yeah, which is called as kable underscore stylin. Styling. Just add this, please add this function below this, pipe, and then cable styling, and then you save it. I'm getting error now. Yeah. So is it better now?
So what's the cable styling?
Cable styling, yes, yes. Cable underscore styling. And then your table will look like this. Let me make it full screen so it will look better. Yes, much better table.
Yes, sir, got it.
Yes, and there are so many functions inside this, and you can make this table. So many changes you can do in this. So let me just tell you one change which should make this table more beautiful, which is okay. This is already maximized. What should I do? What should I do? I can keep it like this. Yes. This is called as what was that? I think stripe. STRIPET. I hope I'm putting the right in the right place. Yes, you see, now it's looking even better. You got the gray and white differentiation, right? So your table is looking much better. So like this, there are so many changes which we can do in the table. Can please mute because again we are getting some background noise. Okay, I guess we are good till here and we can go next. Okay, any questions still here? Okay, so now see here we used only one function, one operation, which is exactly equal to. But similar way, you can use the less than function, you can use the greater than function, less than equal to function, greater than equal to function, which you used just now, or not equal to. If you want to write in your function, bring all the values, but not this value. So you can write equal to and before that exclamation sign. So R will read it as key except this particular value, bring everything else. Okay, so all these operators we can use inside the function filter. Now let's have one more exercise, how to have a data of penguins with bill length more than 43 mm. So I want all the penguins, but only with the bill length more than 43 mm. So First step is call the name of the data, which is penguin. Then filter the data based upon the variable bill length, and what you want to change, bill length greater than 43. Now it will show you all the penguins data which are having bill length more than 43 mm. So output will be, where is the bill length? This is bill length. So yes, we have 46, 44, 45, 43.2, 43.2, 45, 44, 43.1, but none is less than 43. And like this type of, how many penguins we have? We have 188 penguins who are having a bill length more than, what was the value? 43 millimeter. Is it making sense? Is it making sense?
Yes, sir.
Yes, sir.
Okay. Now let's have one more example. How to have a data of Ginto penguins with bill length more than 50. So this time, earlier we were giving only one filter. Now we want to give two. So those should be Ginto, as well as their bill length should be more than 50. So now we are giving two arguments. So how to do that? First the data, then filter the data based upon the species Ginto. So first filter is the Ginto. I want all Gintos. But within the Ginto, I want all the penguins which are having bill length more than 55. And please do not miss this comma, because this is the first argument and then this is the second argument. Okay. So first filter them based upon the type of the species, and then filter them based upon the bill length, and all should be more than 55. So let's see what is the output. Output is, we have only three penguins. We have only three penguins which are having bill length more than 50, 59, 55, 55, and which are also the Ginto species. Okay, and they live on the island Biscoy, and they have this for the details. Okay, so this way filter function can help us a lot, to transform the data as per the question you want to focus upon. Now let's make it a little more complicated. Now we want to have all the penguins but non-Ginto, so other than Ginto, non-Ginto, and they should have a bill length of more than 45, and their weight should be more than 4 kg. So now this time we are having three filters. So first is data, then filter function, then species, all other than Ginto, means not equal to Ginto, not equal to Ginto. So except Ginto, everything. Then, but also see that bill length should be more than 45 and body mass should be more than 4,000. And then our output is 18. So we have total 18 penguins in this category, which are other than Ginto, and they are having the criteria of that particular length and that particular weight. Okay. Is it making sense? Are we okay till here?
Yes, sir.
My other friends, I'm not getting any noise
Yes,
from
sir.
anyone. I guess we are on the right track. Okay.
Yes, sir.
So we have, yeah, yeah, we have Celine here, Remy here, Siddhant here, Ruin here, and 14 other people. Yeah, please, it will help motivate me as well. If I get some feedback, yeah, are we going okay, or is it becoming, oh my God, this situation. So we can,
No, technically, it is understood going on, some error, something like that. So when a program gives error, then your confidence is down. So somehow I'm trying my best to run, but it's giving some errors.
no issues, no issues. See, even the person is performing data science from 15 years, they will get error. And that means they are trying something good, and error they have to resolve. That's it. So don't worry about the errors and do not allow them to demotivate you, of course. So, and gradually, they will go away. Don't worry. Yeah? They will go away and improve. Right. So now we have one more feature which we can use to look at our data and see. You must be thinking, ki, so far I have done a research where we have 200 people, 500 people, and why I need to learn all this. What we are learning, these are the foundation of towards the data science. And when we say data science, and especially in the industry, you may be dealing with a data of 10,000 rows, maybe a data of 50,000 rows, maybe of 1 lakh rows, right? So we never know. So in that case, how to have an idea of the data. We are learning these skills for that kind of data. In future, we hope we will work with the big data and big projects, so that we can handle the big data, and all these commands will we are learning for those works actually, right? So do not see key, okay, this is just 300 rows data, but these functions will work even for the 5 lakh rows as well, right? So think that architecture, and I know you have that in your mind. That is why we all are here. So just little bit motivation from my side as well, so that we continue. Yes. So now we are going to see, if you just want to look at the top and the bottom part of the data, so how to do that. So we have one function, it is called as head. Okay, so we have given key data, then filter the data like this, then just show me the head. I do not want to see the complete data, just show me the head. And head means top 5 rows or top 6 rows. Yes, so this is the head, top 6 rows. Okay, similar way, you can also ask to show just the tail. So it will show the bottom, the lowest from the lower side, the bottom 3, like I have written here 3, so you can write how many rows you want to see. You can write it for head as well, and you can write it for tail as well. So if you do not write anything, by default it will show you 6 rows, tail as well as head. But if you write the number of rows, then like I have written here, show me the data according to this, but show me the bottom 3 observations, that is called tail. So we will see only the 3 observations. Okay, this feature is very important when you want to make sure your data, let's say you have a very huge data of 1000 rows, 5000 rows, and you want to make sure your data is same at the bottom and at the top, right? So everything is going okay in your data, right? That is one good function. Then yeah, now I have work for you, and you can take 10 minutes for this. If you do early, it's good. And you have to now write the codes so that your output will have chin strip penguins, I hope my spelling is correct, are with the bill length more than 45 and weight more than 4 kg. Oh, I have written 4 kg. Okay. So 4 kg. Yeah, I made it a little tricky. Okay. Yeah. So let's see how you'll do it. Because body mass is given in grams. Yeah. Yes, please try this. Yeah, Celine, I'm looking at the screenshot you shared. So let me see what is the scene here. Okay, error in file. Okay. Celine, by looking at your error here, shared error, I think you need to call the package, this one, tidyverse, as well as the cable extra. Are you sure
Okay.
you have activated both the packages, cable extra
Yeah,
as well
sir.
as tidyverse?
Yeah, I activated a 10 years cable extras.
But still you are getting this error. Okay. Mm, okay. Can you share the picture of what we are having before this? Because see, your error is at line number 133. Okay. Can you just share the picture of the line around 133, because the error is
Okay,
there.
sir. Okay.
Because if
Okay,
you
sir.
read the error, it's saying line 133, and this is the error.
Okay, sir. Thank you, sir.
Okay, Siddhant, good. Filter species, chin strap. Build length, mm45, body mass 4000. Yes. Others, I'm sure you will not look at Siddhant's code and you will work on your own codes. Yeah. Yeah. Mm. Okay, you do one thing, Celine. 133. Those back ticks. Take them near to the upper one. Okay, because those back ticks belongs to the upper part. And then
Okay,
after
sir.
131, create a space of one line. Then you start the next chunk.
Okay, sir.
I'm not sure, but that may help you to resolve the error. Yeah,
Okay, sir. I will
you
show,
can
sir.
try that.
Check.
Another reason could be you written penguins, then filter write dot csv, and for write dot csv also you need to have library read r. Okay,
Okay, sir.
that package you can try that. Or did you make folder data in your project so that it can
Yeah,
save
sir.
there? Okay, then make two changes only. Write library read r and create space between the two chunks. Okay,
Okay,
right,
sir. Okay.
right.
Thank you, sir.
Okay. Like if other participants are trying, so we wait. Otherwise, we can explain and we can go to the next slides. Or should I wait? Okay. I received from Praveen. Mm. Praveen, where is the output?
Sir, no output.
No output, but it
Yeah,
should show some
it,
output. So
it's
instead of
showing
writing in the console, why didn't you write in in your document, and then it will show you the output?
document means where.
Means R script, the progress document which you are maintaining, R Markdown file.
So I'm typing in that only. I'm not typing in console.
Okay, because I am seeing it in console as well, so I thought you might have typed in console. Okay,
No, I've
but
typed.
as per your thing, there is only one penguin, which is species feature and this, and then summarize. So how come is the difference? Because Siddhant says there are 18 or 19 penguins, and your result says there is only one penguin.
Yeah, that's why I was worried. Where are my penguins?
Yeah. Both of you have used the. So let's see what is. Okay.
There are a total of 15.
Yeah, Siddhant. But then why Praveen is getting one? So Praveen is making mistake because 15. So Praveen, you did something tricky,
I think there
and
is something
even I'm not able to
different.
touch it right now. Okay, what is tricky you have done? Okay, so okay, I got it. Mistake is I think for the body mass, it is G or just okay. I
Sir,
think it's
maybe it's about summarize the function, not summary. Maybe it is summarize 100 but not
oh, the function is wrong. Okay, the
it is
function is
summarize, not
summary,
summary.
not summarize. Yes, 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 yes. Okay. Yes, Praveen. Thank you for the help. Yes. Yeah, Praveen, that was a mistake. So the function name is summary, not summarize. Yes. So
But
error in the
now
file. Okay, Celine, we are getting error here again.
not find function.
And write underscore CSV, not dot CSV. Celine, write underscore CSV, not dot CSV.
Okay, sir.
Yeah,
Right
write
answer.
that. Yes. Okay, so last 30 seconds. So after that, we'll see the like Nagojan, your output is looking very nice because you have used the, I guess, a nice table. Yeah, so it's looking good. Yeah. Okay, so time up. So uh, yes, so Praveen has reshared. Mm, okay. Error in this function. This could not be found. Okay. Actually, these functions comes with the package tidyverse. So make sure that you have tidyverse. Okay. So what we need to do is head and then the filter and okay, sorry, we have to write the name of the data, then filter species, bill length, and then body mass, and then just look at the head so that you make sure that you are doing right. Okay. You have mentioned summary is good because that is also telling you what is the summary and what are the different penguins inside that. So it's good. Yeah. So output will be like this. Okay. See, so you have six. But why my answer is six? I told species change.
Sir, you have written head. You have written head, so it is
Oh,
six.
yeah, yeah, yeah. I've written head, yes. Yeah, sir. That is why. Yeah. See. Yes, so cool. We are here, and then let's go to the next part. So now let's learn the next function. Next function is the select function, which helps us to choose some particular variables from our data. So let's say our data has variable 1, 2, 3. So select can help us just to have one specific variable which we want, like this picture. So this is what selects do. It will left all these gray and it will take only the variable in which we are interested. And this interested variable could be anyone, this one or this one. So do not think only first variable, any variable, but it will select the variable. So the function is select. So now let's see how to have only species variable in data. So we do not want any other variable, we want only species variable. So it like go with two lines, penguins, then select species, and your output will be only species. Okay. See, if you can accept it, with kindness, I accept it. I was always very afraid freezing the columns, removing the columns, adding the columns, because I will always very scared ki whether, because you are dealing directly with the data, and you are never very sure ki whether your data, you did not delete anything by mistake, right? So here at least you can, remove the codes and your data is there intact at least, right? So that is very, very, calm for me at least, ki, okay, I'm not directly harming my data actually. So I'm doing all the changes in the data through the codes only, right? So now our data has only one variable, which is species. Now let's say how to have a specific range of variables. I don't want only one variable, I want a range of variables. So I am saying that in this new data, I want the variables from species to the bill depth. Okay. So all the variables starting from species till the bill depth. So in between all the variables will be included. So output will be, there is a species, there is an island, there is a bill length, there is a bill depth. Okay. So there are only two variables between them, and starting to in between and then the end. So and then if now you work only, if you want to work only upon these variables, you can go ahead and you can do the work on only on these variables. So these are the selection or selecting the variables based upon the range. Next, you can also select the variables based upon their location. Like in the data is very easy to see key variables are like column number 1, column number 2, column number 3. So in that case, you remember key, like you do not remember the names or the names are very big. So you can just say, I want all the variables or all the columns from 4 to 8. So these are the locations of those variables. And now your data will have all the variables location from 4 to 8. So at 8th, we have the year, then we have the sex hair, then we have the body mass, then we have the flipper length, and then we have the bill depth. Okay. This is if you do not remember or you do not want to write the names of the variables. You can just call them by their location. And if you write select one, so it will only show you the variable which is at the column number 1. Okay. Now let's go next. Now how to have a specific variables in the data. You do not want to give range, you do not want to give location. You want some specific variables anywhere in your data, right? So for that, you have to write again manually, like I want species, I want body mass, and I want year. So after every argument, there is a comma, species, comma, body mass, comma, and then year. Now your output will have only 3 variables, which you mention exclusively. Yeah, I want only these variables. Okay. So you have the species, body mass, and year. Done. Now, you can use it in another way as well. Like you remember this function C, Connecticut? It combines actually the things. So you want to combine this, but you want to minus them. So other than this, everything. Okay. So I told earlier as well, there could be several ways to do the same thing, right? So never try to memorize the codes. Just we should try to understand the logic and apply the logic at different places, and then try to understand whether the logic is working or not working. Okay. That is the best way to learn the data science actually, not mugging it. Okay. So we know using C we can combine the things. So you combined all these variables, but then you have added the minus here. Okay. So means dash here, and you are saying that select everything minus these combined things. Okay. And now your output will have all the variables except those variables. Okay. This is the work of the select. Right. Now let's learn the next function, which is mutate. Okay. Any questions about the select function? Okay, I got output from Celine, and still we are getting error. Error cannot file write this. Okay. Okay. Second error is error cannot 136. Okay, Celine, quickly can you go to here like this? Yeah, go to here files. Go to your file folder, and then click a picture of this, and then please share with me. File folder like this, and let me see what are the different files are there, so that let's see why we are getting an error.
Yes, sir.
Yeah. Yeah, let's sort it that itself first. Okay, so being time, if some of you want to practice the select function, so you can practice the select function, like choose the variables, minus the variables, select the ranges as you like, and you can practice that, and then you can share as well. Okay, so the error is because you do not have a data folder in your R project. So what you need to do is, see, we have new folder option here. Celine, are you able to see?
Yes, sir. Yes, sir.
Yes, there is a new folder option here. Click on this new folder option, give it name data data, and then just say okay.
Okay,
Okay,
sir.
it will create a new folder with the name data. And now if you
Okay,
run,
sir.
I hope it will be solved. Okay,
Okay, sir.
yeah, please try. And others, if you have used the what do you say, if you have used the select function, you can share the results with me. Yeah, this is how select works, if anyone needs. And like I'm just saying Siddhant, but it is for everyone. Like Siddhant, what we did, updating of the values, it will work everywhere, with every function, not only with the, filter function. Okay.
Yes.
Yeah, like updating of the results will work with the every function. If your data is changed, you change something, your values will be updated automatically. But yes, one thing you have to be very careful. If you change the names of the variable in your data file, then your sheet will not be updated automatically, because in your codes the name of the variable is different and your data file name of the variable is different. So give a lot of time, think, and then you give the variables name and keep them short. Like you see here, keep them short, don't leave any spaces, and keep them in the lower orders, because naming you can change later as well. But do not change them very frequently, otherwise your scripts, our scripts will not work properly, because and you will be thinking ki I changed only the name in the data, why script is not working? Because R is reading the variable name from the data. If that you change the name in the data of the variable, so how R will know? So R will not update the names of the variables, like this the top one. Okay, so do not change them very frequently.
Okay, sir.
And we are getting again error. Okay, Celine. Okay, now you're getting error because after Ginto you have written pipe, but there is nothing after pipe. Yeah,
Okay,
you
sir.
cannot leave it empty. Yeah.
Okay, sir.
Yes, you have to remove the pipe, then you will get definitely answer. Yes.
Okay, sir. Thank you, sir.
Yes. Because pipe means something should be after that. Like you are saying Ginto, then, but that then is missing. That's why it is as error. So yes, Alicia, nice output. Okay, good, good. Okay, right. So, okay, what selection Alicia has done? Alicia has selected island. Okay, she has selected 5 variables out of 8. So, island, bill length, bill. Okay, this good. Okay, Praveen has selected 2 species, bill depth, and furthermore. And you're right, getting at 1, 2, 3, 4, 5. Okay, and which you can click and you can see further. Okay, so good. I guess we are making very good, fantastic progress. So all of you are really doing good work. So now let's go and learn the, okay, may I go to the next function, or you are practicing for the select?
And just an observation that uh, when the output is coming and it is we can go 1 2 3 4 5.
Mhm.
So is it like a dynamic and it will be similar manner, it will be available on HTML? It's like big
It is
table.
available only in HTML, because it will
Okay.
not work in PDF. It will
Right,
work
right.
only in HTML. Yes.
Then it is a fantastic tool then, you
It
know.
is. It is
Yes,
actually.
yes.
It is. Especially in the slides, in the presentations, and you can and that is actually you're moving towards the big data. Like,
Right, right.
when you have lots of output, lots of data, now there is no more restrictions. And if I can exaggerate a little bit what I read about the HTML, in future it is going the only way to make the best slides, because it gives you lot of opportunity to explore. HTML means like a web page. So whatever you can do in the web page, you can do in these slides. Integrating HTML codes, integrating Google Map Live, integrating tables of, like you have shared the tables right now, right? So HTML is a fantastic way to give the presentations. Yes. So which we'll learn tomorrow, how to do that, make presentations in this.
Thank you.
Welcome. So let's learn the mutate function now. A mutate function is to calculate a new variable based upon the earlier variable. So let's say here we have the 3 columns, 3 variables, and we'll calculate the 4th one based upon the or we may just say that we are adding a new variable. It's not necessarily just a calculation, but we are adding a new variable. So that is also a mutate. So yes, Celine, you must be very happy. Finally, you got an output. Okay. Yes, that's good. That's very good. Yes. And I am very happy when we are able to get the work done. Yes. Good. Okay. You shared something. Okay. Okay. Good. 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 Now you're getting all the outputs actually. Good. Very good. So now let's go and learn the mutate function. So how to convert penguin body mass from grams to kilograms, right? So it looks very weird to say 4,000 weight. So it looks like, oh my God, so heavy. So normally we calculate weight or body mass in grams. And 1 second, let me check the another phone from which I'm connected to the internet, because this internet will go away otherwise. Yeah, we are connected. Okay. So let's convert and that gram into kilogram and make a new variable, or just change the older variable. So that is what we are going to do now. So for that, we have the first data, then we want to use mutate function. Okay, it means we want to calculate a new variable. We are going to add a new variable in the data. So first thing, you need to write the name of the new variable. So because you have to give a new variable and you are not making a change in the data file, so you have to write first the name of the new variable. So new variable name is body mass kg, right? Body underscore mass underscore kg, because we want to convert gram into kg. And this is the name of the new variable, equal to, after this you can write what calculation you want to do. So we know that if we divide this gram values by 1000, so all our values will be converted into kg, right? So we are saying that this complete column, this complete variable body mass gram, divide it by 1000, and our values are done. Where is our value? Values are here, body mass kg, but because of restriction of this thing, we are not able to see it. Okay, but now let's go and see it. Why not? So we also know there is a function called as select. We learned already. So I do not want all the variables. I just want gram, means like body mass variable, and then I want to make the mutate. So body kg, and now if you see the output, now you have only 2 variables, body mass gram and the new variable body mass kg. And now you can save even this file, and your new file will be having a new edit variable. Okay, you can save it into CSV, you can save it into Excel, both the formats, right? Okay, and I hope you are doing the right calculation. 375 divided by 1000, 1.35, 3.75, right? So gram to kg. The way is penguins, then select the gram, select the mass variable, then mutate this mass variable by a new variable named this, equal to body mass divided by 1000. Now you can do any change with this, like you want to multiply all the values by 2, you want to half all the values by 2, you want to add to every body mass 100 gram extra, so you can say body mass gram plus 10, so every value will be added by 10. Okay, that is how it works. And And okay, now what I did here, but now let's say we do not want both. So we get a confusion. There's a gram as well as kg. So what we can do here is we can say penguin, then mutate body mass this, and also mutate one more variable. Okay, so I'm sorry, I was doing something else. That now I want to add two variables at the same time. One variable is body mass into kg, and second variable is a calculation of bill of the penguins based upon their length and based upon their depth. Right? We know that we both have we have the both numbers. So we are calculating a new variable with bill, and we are doing the length multiplied by depth. And now let's see the output. So again, it is where it is. Yeah, where it is. What was the name we have given? Bill, right? So we are having species, we are having 10. So definitely we have increased. Yeah, it's here, Bill. Okay, it is here, Bill. Okay. So again, it got hidden because of the limitation of the screen, right? So, but we can bring it up by saying that do all this mutation and everything and select only the new variables which we calculated, which is body mass kg and the bill. And now the output will have only body mass kg and only the bill. Is it making sense? Are we okay?
Yes, sir.
Okay.
So can you show the code?
Yeah, please. So first I created the new variables, and then in the next step, I told give me only the new variables which I created. So first I mutated and created new variables. Then I selected only the new variables which are created. Okay, like if I can mention, Siddharth was writing like in that straight line, comma, then one, then one, then one. That makes reading code a little difficult for us, and then we have to see, okay, how many arguments we have. So one good also habit is whenever you have to put comma, after that press enter and take the next argument to the next line, so that it makes very clear for you visually ki, okay, penguin data, then you created this variable, then you created this variable, and then next line you selected this body mass, and then you selected the bill. So after comma also you can press enter and take the next argument to the next line. And so that in case in any respective argument you are making mistake, so R can exactly tell you in this line you are making mistake. If your all arguments in one line and R is saying ki mistake is in line number 1, line number 2, but how do you know which function you are making a mistake? So one line, one function, it will help you to resolve your error quickly. Siddhant, is it making sense what I'm trying to
Yes,
say?
sir. Yes, sir. I'm trying to code it in the manner that now every variable goes in a different line, so that I
Yes.
eventually understand where the problem is.
Exactly. So like I did not say it from the very start because it looks ki, oh my god, we have to put every time this many steps. But no, gradually when you become little familiar with it, then we can I can enforce these habits on you ki, okay, practice these habits. So and gradually our codes become bigger. So then we have to make it visually understandable and not a pain in the eye, right? So that's why. Yes. Okay, I guess we are okay. And now let's learn the next function, which is called as arrange. And arrange will arrange your all the values based upon the appropriate row or observation which you want, according to which you want to arrange it. Okay, so let's say our data is like this, and then you say ki arrange according to as per one particular value, and your whole data will be arranged in a particular order. So let's see how to get it. How to have data arranged by the ascending order of the bill length of the penguins. So we want the whole data to be arranged uh, as per the ascending order of the bill length, right? So data penguin, then arrange function, then arrange everything, bill length That's it. And answer is bill length And if you see, by default it is in a ascending order. So 32, 33, 33.5, 34, 34.1, 0.4, 0.5, 0.6, and the whole data is arranged accordingly. Not only the bill length. Okay, whole data is arranged according to the bill length now. Okay, then again, this is one fear which luckily, when I started research, I rarely worked with the Excel calculation. So I don't know, but whenever I try to work, it always give me the pain, and I always came back to the R for using these commands. And somehow, okay, I will keep it for later. Okay, so okay, so this is how we arrange the data based upon the value of one particular variable. Now let's say you want them not in ascending order, but you want them in the descending order. So we have a function, it's called a DESC, which is called as decreasing. And now you can use this function decreasing anywhere where you think it makes sense, and you want your data to be in descending order, so you can add this function descending, and the values of that variable will be in the descending order. So here we are doing two things. Number one, we are saying bill length in the descending order, and after that arrange the whole data based upon that descending order. So we are doing two things, two functions, function within a function. And now if you see, our data bill length is in descending order. So first we have the highest length, then 58, then 55, then 55, then 54, and whole data is arranged accordingly. Okay. This is the arrange function. And now let's say arrange as per the species. So when you are not saying it, so it will take automatically A, B, C order, so that if you see now the first Adele, and then the next, and then the next, alphabetical order. So now let's learn the function summarize. So summarize your whole variable based upon the variable, based upon the column and variable. Yes. So summarize is like calculation. You are making new calculations based upon the variables you have. Okay. So let's see. So how to find mean bill length of all penguins. Okay, I want to find the mean bill length of all the penguins. We have the column bill length, so I want to find the mean of that. Of course, we can find that through the summary function also, but let's see if we can find through this one. So penguins, then drop underscore NA. Okay, this is very important function. Remember this. Sorry, yeah. There are few functions, especially statistical analysis functions, which will not work if you have any missing values in your data, right? So for some statistical analysis tools like summarize here, we cannot have any missing value in our data, and we know that in the penguins data we have missing values. So if you want R to drop all the missing values from the calculations automatically, so we can use the function drop underscore NA, right? So all the observations, so what it will do, it will remove the whole row. The whole row it will remove actually. Complete row is gone. And we know we are missing values very less. So it will drop all those respondents, okay, all those samples. So to use the summarize function, we also have to use the drop function. And it is very, very important for us. Once again, because 50% data is gone, otherwise it will stop. Yeah. So and then we can call the summarize function. Okay. So drop NA is not restricted just here. You can use it anywhere. So, right. So anywhere sensibly you can use key I do not want any missing value in my calculations. Or when you get an error key your data has missing value, that's why you are not able to run this, then you can use the function drop underscore NA. So your all missing values will be removed from the analysis. Okay, so penguins, drop all the NA respondents, then summarize mean bill length So we are summarizing and creating a new variable, and new variable should be the mean length, so equal to mean of bill length So this is the name of new variable, and how this new variable is formed, equal to mean bill length So mean of all the values in the bill length, and your output will be mean bill length 44.0, right? But it is not of that much useful for us because we can get this value even from the summary function. It becomes very helpful for us when we use another function which is called as group by, and then we summarize, right? So let's see, we want to find the mean value, but for each type of the species, then it is more helpful for us, okay? Because this value was not given by the summary function. So we want the mean value, but species wise. So this is a fantastic use of actually this. So yes, penguins, then drop NA, then group everything by species. So first we want the whole data to be grouped as per the species, okay? And then you summarize, right? Then you summarize. So now you see the output. Now you have a good output, which is more helpful for you. For Adelaide, we have the mean 38. For Chinster, we have the mean 48. And for Ginto, we have the mean 47, right? So this makes more sense. So now I will give you the task. Uh, First, you run group by for the different categorical variables, right? Different, like we have the island, we have the sex, and we have the species. So group by the different variables. First you do that, and then let's see how the value, how the numbers, how it is grouping, okay? And then share the data with, share the screenshots with me, okay? Okay, being time, if anyone got any error or stuck somewhere, so please share your error and we can work on that. Yes. And if you want me, shall
Sir,
I?
I'm really sorry, but sir, there's a bit of a construction going on in my background, so I couldn't hear it. So could you just type it out? What do we need to group by?
Or
you could just repeat it. Sorry, group by
you
species.
can use any categorical variable you want.
Okay. Sorry.
Okay, Celine, we again got error. Let me see why. Unexpected end. See, again, the issue is same. There is a pipe, and after that, nothing is in the pipe. Line number 189.
Okay, sir.
Yeah, there is a pipe at the end, which is not required.
Okay, sir.
Okay, let me also try in the sheet here. So session number 4, and we are learning why make it one new session. Yeah. Now let's do use group by function. Okay, we have data penguins and pipe and group by. I want to group by them by their sex. See, let's see what is the output. Okay, we are getting an error. Okay, not that much useful. 1 second. Yes, Alicia, that's good. Fantastic. Yes, species, island, and bill length. Okay. Okay, pretty good. Okay, but why I am getting an error? Is it because 1 second. Okay. Well, it is not a good way. Or I need to read it full. Okay, I'm not getting what I am looking for. Okay, let's do this as well. Head will not help, of course. Okay, I can do select. I'm also just trying to do little experiment. I don't know how it will answer, but let me try. Tick. Okay. Okay, I think even in itself, this is not so good for us. I think it is good for us only when we summarize it. Yes. So, summarize. And let's say we found mean, right, last time. So this time let's find percentage. Or we say proposition. And proposition of I want count function and want to count them. Let's see this output. Oh, you cannot do that. I think I have to use mutate. Yes. Oh, not even that. Then what do we need to do? Count. Okay, Celine, we got one more error. Error cannot subset columns that don't exist. Okay, the name of the variable is wrong somewhere because it's not able to find that variable. Body mass kg does not exist. Okay, yeah, Celine, you need to write the select function after the mutate.
Okay, sir.
Or wait, convert that kg in the select into the gram, because in the penguin data there is no variable with kg. So how it will select? So just convert into, just remove the k and keep it g.
Okay,
Okay, and there is no function, there is no variable as bill also. So what is good thing is take that line from there and keep it after the mutate, below the
sir.
mutate. Change the order, it will work. And I was
Okay,
trying
sir.
to do little smartness here, but I'm not getting anything good here. Yeah, so
Okay,
I
sir.
will stop.
Thank you, sir.
Yes. So okay. So even I'm not getting any good result here, so I just stopped looking stupid. So yeah. So okay, anyone is trying, or we are good till here? Then we can go next. And let's have last function for today. How to find species by mean bill length of the penguin and total number of penguins in each species. So several things we are going to do together. The total number of penguins as well as their bill length. So we are going to add one more function, total numbers. And for that we can use n, which is called as, yeah, oh, I should have used n, not this. Okay. So data, then drop the missing values and then group by species, then summarize bill length, mean length of the bill, and then this is the calculation of the mean length, and then also do n equal to, and how many are the total numbers. So this is a way actually to calculate. N means it will calculate how many elements inside that particular variable, and we have given the new name is n, and it will calculate in this mean bill length how many elements are there actually. So let's see the output. So see, in the Adelaide we have 146, in Chinstrup we have 68, and then Ginto we have 119. This is the mean length. So what actually we are doing here is we grouped by the species, then we summarized and found the mean length, and then we also found the numbers inside that particular variable species, and when we summarize it. I hope it did not become very, very cumbersome. It may be, but it's okay. Gradually, it will become okay to understand and go with the flow. But for today's, I think the main and main functions were to understand. And see, summarize, group by, it's more of a practice and more of getting more errors and then rechecking them. So even you see, even I was not able to try to get successfully when I'm trying something on the spot, and which is normal. So it requires more practice with the data to handle it, pretty well with when we're doing transformation and wrangling part, right? Okay, so we have some 15 minutes in our hand. So if we have some questions, so we can go for the question answer. And for this session and for the earlier session as well, if you have some questions, so we can deal with them. Yeah.
Sir, if you could just repeat the n equal to n portion of this, the summarize. I couldn't understand the last part. Yeah.
Okay.
What is this doing?
See, n function, let's understand this n function. Okay. What n function does for it counts the number of elements. So let's try now. Okay, let me see. Okay, let's write penguins, and then I want to select, I want only variable, and then let's write n. Okay, why it is showing me everywhere? Or okay, now let's see. Let's see what we'll get the output. Okay, we are getting error. Okay, and we are getting, okay, if I write okay, wait, n. Okay, again, and what if I write count? Okay, see, the n is actually work like count here. So if you see, I created a new variable. The name of the new variable is n. Okay, and it gives me the number, like how many female and how many male. It counted that for me, right? So similar way, actually, this n should work. What I was trying, but I think I'm failing there. So let's take help of R here. Let's write in the console. Where did it go? Yes, right. Let me try what help I can get here. Okay, let's see. Okay, so these functions return information about the current group. So n works only with the group, that is the first thing, or the current variable. So only inside specific context like summarize and mutate. Okay, so it will not work as a alone function. It will work either only in the summarize or only inside the mutate. That is the one thing. So n gives the current group size. Okay, okay, got it. Is it clear, little Siddhant?
Yes, sir. Like
Now
it sort of counts it, but we always have to use it inside a particular function. Like it has to be contextual. It can't be used in its own self.
Yes.
And sir, when we were using group by, like when we were doing group by, it was sort of showing us the entire data in itself again. Like let's say when we were doing group by, I don't know, like let's say just when we were saying sex, like group by sex. So it was showing us the entire data. So what did that mean?
It is arranging your data in a particular order. Like let's see the result. This one, right? Arrange, right? Arrange, you're asking, right, Siddhant?
No, sir. Sir, group by.
Group by, okay. Okay. Yeah. See, here we are telling to group your data based upon one particular categorical variable. So what is the benefit we are getting here is, now we are not just getting the mean value, but we are getting the mean value as per the categorical values of the variable species. So first, I think if we understand the sequence, that will help. So what we did first we grouped our whole data by the variable species. So now our data is now little imagination that our data is now grouped by the species. How many penguins per species? Okay. after that, we also added a calculation. Now also add a calculation of mean bill length for the mean of all the bill length. Okay, so but now we will not get only the mean, but we'll get the mean uh, per element of the group, because before this we have immediate function ki group the whole data based upon the species. So what it has done, first your data is as per the species, and then you got the mean values as per the species. But if you remove the group by, so you will get only a single value, which is the mean value, which is not of very useful for us, but it becomes more helpful when we can first group our data based upon one particular categorical variable, and then we do some calculations for those respective categories. Okay, I'm not sure I'm making much sense.
No, sir, I got that part. But when we were replacing species with, let's say, sex, when we were doing over here, the entire data was coming in without actually it being filtered in a certain manner.
No,
Why
I
was
didn't get. Why? What is happening?
Sir, when we were doing group by sex,
Mhm.
it should have either come in either male or female, right?
No, I did not use group by. See, I was saying select actually. I did not use group by so far.
Oh, okay.
That is what I think that is what the mistake I did. So I should have used the group by. Let's try now group by
Yeah.
X. Okay. Now. Okay, but again we have all the
data. That's what I was.
Yeah, we will do this. Select, then select only variable sex. Okay. Okay, so see, now we have only sex. So see, now the problem is we have selected only the one variable. I think we should select one more, then it makes sense. Like here as well. Okay, so see, now what it has done, we have actually three categories here: male, female, and right, because we
And
have
not available.
NAs as well. So let's drop the NA. So
Yeah.
drop underscore NA.
NA.
Then. Yes. Now you see, now our complete data is grouped by male, female, male, and why it is 1, 2, 3, 4, 4. Okay. So now we have only the things which are having the variable sex and then having the variable year. But still, it is not that much useful for us, right? It is not that much useful for us, right? So because maybe we are not able to make the right combination. So the right combination is group by and then summarize.
Then summarize, and then we can use the count. So we'll use
Yes.
the n equal to n function over here.
Yes. So actually, that is the right combination: group by and then summarize some feature of those penguins. So let's say if you want to summarize and bring the mass equal to we have the, what was the name of the mass variable? Body underscore mass. Yes, we got this. And now let's say multiply this, divide this by 1,000. Now our mass should be divided and categorized as per the gender. Okay?
Gender, yeah.
We hope so. Let's see. Okay, but yeah, you see.
Sir, maybe we need to add n equal to n
Yes.
in front of it.
Yes. Now if we do that thing, n equal to numbers, because we can use only inside the summarize. So it will give you the number as well as the this. No, what is wrong? Why it's not coming still? Something is wrong. What is wrong? I don't know. Okay, wait. Okay. I think we can try it later on, but for time being, what is wrong? What is wrong? What is wrong? What is wrong? This. I'm not able to catch any mistake here. We are doing exactly the same thing what we did here. Okay. 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 What could be the mistake? No, I have no idea why it is not working. Okay. Let's try the species only then.
So maybe we'll figure out like another combination and then
Yes.
perhaps
Yes.
tinker
Maybe.
around with it.
Yeah. On the spot, we always get something trouble. No, it's not working here as well. So I have no idea why not. Right. So, okay, then we can close here, not a big issue. So we can find it out tomorrow as well, why it was not working.
Sir, maybe because it's not an integer, it's not an integer value. Like when we're grouping by, let's say, I don't know, by sex, maybe it's not, and no, even then it will be, sorry, no.
No, see, here also we have factor, sex is also a factor, right? Here also we have numeric value, weight is also a numeric value, right? The only thing is that we are not creating a single value out of it. Okay, I got it now. Let's see. Let's see now. Let's find the mean of this. Okay, I think we have to create a mean single value, then it will divide those value as per the groups. Exactly. Okay, see, now we got the, okay, Siddhant, now we got the answers.
So we need a singular value for it. We cannot have multiple values.
Yes. So we need to have a single value, and then that single value will be divided by the group. Okay, that is the point. Okay, great. So it will not work for the, if we put all the values. Okay, so we have to calculate one single value, and then that single value will be grouped as per the categorical value.
So essentially we'll need something like a mean median mode so that it comes out to the same value, and then we can perhaps like process it into a singular. Yes. Okay, got it. Thank you, sir.
Yes. Thanks to you, hanging with me, and we got it done. Yes. So yeah. Okay. And now the nice thing is that you can make plot based upon this. Like we have 5 minutes more. So let's see. See, now you have this one. So again, all are looking here. So let's increase my level of embarrassment here. So where did it go?
Good joke, sir.
Yeah, why not? Yeah. See, let plus, and now let's make a ggplot as well. Okay. So we already have the data, so no need to give the data. But we know what are the new variables we have calculated. What are the new variables we have calculated? We have species, we have mass, we have n. Okay. So I want to I want to plot mass and n based upon the species. So I want to calculate this new plot. So ggplot this and aesthetic value. So I need to give x. So I'm very bad with memory actually. So mass and n. Okay, this is done. Then these are two numeric values, so we can only make geom dot that geom line, no, geom point. Yeah, geom point. So let's make a plot. Okay, we got an error. Why? Data frame did this. Aesthetic. I think it wants me to tell exactly what is happening, or that is not error. Error is something else. Okay, what was the okay, we have the mass and we have the n. So something is wrong here. That is why it is saying we cannot do that. So okay, we cannot make the plot of it because it is a single value. Mass is a single value, so that is why it is saying we cannot make the plot out of it. Okay, got it. But we have mass 3 values. Why it is not making a plot? Let's try bar. Let's try only bar, and now try. Okay, again we are getting error. So okay, so I increased successfully my level of embarrassment. So yeah, so no issues. Okay, yeah, but it's okay. Things worked on, but no problem. So it will work maybe next time. So never mind. So we had a good session. So I understood a lot of new things today. So then in the next session, we will talk about the Sharingen, how to make slides using Sharingen. And I will also share the assessment with you. So most probably in an hour or sometime tomorrow, not today, of course, tomorrow. And yes, so yeah, we can say bye-bye for today, I guess.
Yes, sir. If in case any other questions, any other small
Sir, I
questions,
have one query, sir.
Yes,
Sir,
Imran, please.
you used a drop function to